to focus on today is taking that ideal gas law, PV equals nRT, and substituting for density, actually solving that ideal gas law for density. So let's review for a minute what density is. Density equals mass divided by volume, right? So little m is the mass of the gas. And remember that N, which is our moles, is simply the mass divided by the molar mass, or grams per mole. Now, what do we do with that? Well, we can do a little bit of substitution. Since we have our ideal gas law, PV equals nRT, we're going to substitute for N. And N, we said up here, was mass divided by the molar mass. So now when we substitute, we're going to get PV equals the mass times R times T divided by the molar mass. Okay, so we just substituted for N, and now what we're going to do is switcheroo here. PV and capital M are going to switch places, and we get the molar mass, capital M is the molar mass, equals the mass times R times T over PV. But remember that we said the definition of density is mass divided by volume, right? Mass divided by volume equals density. So that means we can take this equation and rewrite it as the molar mass equals the density times R times T over the pressure. So the molar mass equals the density times R times T over the pressure. Sometimes we call this the kitty cat equation because M equals dirt over P. Get that? Dirt over P. Yes, I'm sure you got that. And we can rearrange this equation and solve it for density. If we want to find out what density is, we'll just take M times P divided by RT. So either one of these equations turns out to be very useful. Molar mass equals dRT over P, or density equals molar mass times P over RT. So grab your calculators. Let's go ahead and do a practice problem. Let's calculate the density of carbon dioxide gas. Okay, at 950 torr. Notice we're throwing in a different pressure unit there, and 25 degrees C. Okay, so if we want to find the density, we need an equation for density, and we just solved on the previous page that density equals molar mass times the pressure over R times T. So let's go through these four variables and see if we know what they are or if we can figure out what they are. So capital M, remember we said is molar mass. And what's the molar mass of CO2? 1 carbon plus 2 oxygen, which is 12 plus 2 times 16, or 44.0 grams per mole. Okay, pressure. It's 950 torr, but I think we're pretty adept now that we cannot leave an answer or pressure in units other than ATM. So 1 ATM is 760 torr. That's our conversion. So when we do that math, 950 divided by 760, and we get, with two sig figs, 1.3 ATM. Now, R we always know, 0.0821 liters times atmospheres over Kelvin times mole. We always know R. And then our temperature was 25 C. We have to switch that over to Kelvin. So we get 298 Kelvin. Okay, so we're good to go. Now we just plug into the equation. Density equals molar mass times pressure over R times T. I'm going to keep those units all grams per mole is our molar mass. Pressure is 1.3 atm. R is 0.0821 liters times atmospheres over Kelvin times moles. And our temperature was 298 K. Let's see what cancels. Moles and moles go away. Kelvin and Kelvin go away. ATM and ATM go away. So what's left behind? Grams over liters. Density is mass per unit volume, so grams per liter works perfectly. Excellent. So unit-wise, we're in good shape. Now let's do the math. 44.0 times 1.3 equals divided by, in parentheses, 0.0821 times 298, close parentheses, equals, and with two sig figs, we're going to be at 2.3 grams per liter. That's a really low density. 2.3 grams per liter is the density of carbon dioxide. Okay, I'm going to write a problem up on the next page for you to do and bring to class tomorrow. So here we go. We have a 250 milliliter sample of a noble gas. So this is in group 18, a noble gas at 88.1 kPa. 7 degrees Celsius, 7.0 degrees Celsius. And it has a mass of 0.378 grams. 0.378 grams. And I want to know, what is the molar mass? And from the molar mass, then identify the gas. So what is capital M, the molar mass? And identify the gas. Is it helium, neon, argon, krypton, radon? What is the gas? So from the molar mass, you should be able to do this.